Here we go. So we're looking at example number 5. We'll call it part E. Once again, given the fact that there's not a quotient rule for integrals, we'll pull up the denominator, give it a negative power. That did create a product, and there's not a product rule. Now, there's no guarantee what we're showing you here is going to work on every integral you're ever going to see the rest of your life. We're in Calc 1. Hopefully it'll work. When we see a quantity to a power like this, quantity to the -1 power, we would hopefully realize that it's possible. It's probably going to work because we're in Calc 1, but don't think this works for the rest of your life. We can set u equal to that. So I don't want you to leave this class thinking that you can do every integral that you're ever going to run into using substitution. It doesn't always work. When you get to Calc 2, you learn other techniques. The bulk of Calc 2 is, in fact, integration techniques. So anyway, we differentiate both sides with respect to x in order to build the dx. We clear fractions. This is the same thing we did on a previous assignment when we did substitution, and we're left with 2x minus 8 dx. All right, we have an x term minus a constant. This has promise. We're in Calc 1, it's working, all right? So anyway, as we did on the previous example, I tell people you really can only fix that first term and cross your fingers and hope it will also work on the second term. So, how do you change a 2x into a 7x? Cancel the 2, replace it with a 7. This is still conditional, keeping our fingers crossed. So we distribute, and of course that's going to give us the 7x that's in the original integral. See, we're trying to change this into the original. But this is where we cross our fingers and hope that that second term becomes 28. So, what is 7 over 2 times 28? Let me say that again. What is 7 over 2 times 8? What is it? What in the heck is that when you multiply that? Are you kidding me? That's twice in a row where it became that other number there. Aren't you glad you're in Calc 1 and it worked? If that was anything other than 28, this would have all been a waste of time. Wow. How cool is that? All right. So 7x minus 28 dx is 7/2 du. Now the hope would be that with experience, with practice, and all that, you would realize that this would be the scenario where the power rule will not work, because if you do n plus 1, you would get u to the 0 over 0. I've had people turn their paper in and put over 0 there, and I'm like, oh, you're killing me, Smalls. You can't divide by 0. Hopefully, as soon as your hand, when you did the n plus 1, as soon as your hand wrote 0 there, you hopefully like, oh, wait a minute. This is the weird one where the power rule doesn't work. That's right. U to the -1 is the same thing as 1 over, and 1 over is the derivative of natural log. All right, see how they work together. So this is the scenario where the power rule does not work. It is the exception to the power rule. And then we substitute back, and u took the place of that expression. And there we are. Okay? Kaboom. So, I'm hopeful that that was pretty good. I think so. And as far as I'm concerned, if we come back and we'll just take another look at one of these, I think we're going to be in great shape. So, let's do it. That'll be our next example.